Hi, someone let me know if I can be seen and heard.
Yep, you're good in your life.
Great, thank you. So my name is Samuel Zaruba. My background is in security, data science, AI, data governance, things related to that. This particular presentation is an area of both research and expert opinion around human inputs and AI systems, particularly for security-related issues. I have a background in a variety of private corporations, and both with the state and federal level government organizations, one of which I'm currently at now. So this particular presentation revolves around the idea of many business leaders, executives, corporations in general. Let me turn my brightness up a little bit, you can see me better. I think this is an area where it needs more attention. And this is an area where many companies now are adopting AI systems at large across a variety of tasks, some of which can be more sensitive than others. So for example, if you are doing marketing related predictions and the worst that happens is you recommend a customer a bad product, or a not aligned product, that's not necessarily a large negative impact on your bottom line or your security or any of the other metrics you would normally use to judge AI systems, besides maybe accuracy, something like that. But in many cases, particularly areas around, say, fraud, potentially ham or spam type email detection, removing hate speech on social media platforms, all these kind of other more high level uses of AI that are have either ethical or security risk to them, very often these systems are based on supervised learning. I'll show in a little bit that the vast majority of use cases of AI in the industry are still to this day supervised in nature, meaning that these systems depend on human inputs. And these human inputs are of sometimes questionable value. So much of my work and some areas of I study quite heavily are around judging the value of these human inputs and what kinds of risks they are associated with. I'm going to jump to the next slide here in a second, but in general, there's a number of experts that believe any human inputs to any AI system can roughly be only worth maybe 15% at max of increasing performance value. So if you were trusting human beings and their labels and their annotations, regardless of what kind of system it is, it's human in the loop type systems, if it's supervised systems, whatever it is, very often the baseline to the maximum increase in performance due to these human beings providing their input is roughly only about 15%. And I'll show later it even goes much lower than that in some cases. So I'm going to turn it down now, bright screens. So some of the motivation behind this comes from this research that came in the Harvard Business Review in 2018, where there was this notion that human inputs are becoming less valuable because AIs are getting more powerful. And if you look at a large amount of the academic literature, if you look at a large amount of the practical security applications that are coming out now that are using AI and dependent on AI, this number can change drastically based on how high quality these human inputs are. And so knowing how much you can trust your human inputs becomes as important as how much lift or actual real gain you're getting from your labels if you're using a supervised or human in the loop type approaches. So it's important to note that with AI, some of the main areas of adoption are in the financial space, physical security space, cybersecurity space, and really all of these areas of security issues are starting to adopt AI at extremely fast rates. The issue of interpretability here is well documented as a major problem for AI and security, because you want to understand the threat. You want to understand what the problem is, if it's an engineering problem, if it's a human error problem, if it's something else. And all the issues related to privacy, bias, human error, social engineering, your data being degraded or data drift and data poisoning issues can really, most of them be traced back to issues with human beings interacting with the AI systems, either at the training data level or at some kind of higher level, again, like a human in the loop type approach, or even maybe potentially prompt generation and things like that. So a lot of the major ethical and practical issues around securing and making sure your AI systems are compliant with certain new laws coming out around privacy, issues around cybersecurity and other ways to make your systems more robust and less biased, often revolve around these human inputs. Again, making it too bright. So it's worth it to note that supervised systems for a very long time, by their very nature, because they involve more data, more expert opinion, are commonly within the literature seen as more performant than unsupervised systems, regardless of architectures. So regardless of whatever type model you're using, supervised systems for a very long time have seemed to be the preferred method for, and again, most systems in the actual industry are still to this day primarily supervised systems, meaning they're using human inputs at some level. What's interesting is that a vast majority of threats, whether this be social threats, like removing hate speech or hateful images on social media platforms, or whether it is actual cases of fraud, cyber attack, electronic issues around even power failures, things like this, are roughly at the 5% level in terms of both the investigation done to them. So roughly only 5% of threats are actually investigated. And additionally, I'll show later that the distribution of this kind of data roughly is usually 95% benign, 5% actual threats, which is very interesting from a distribution standpoint and an engineering standpoint. It's also very important to note that the vast majority of any security failure are not due to some technical issue of your system. It is not due because you wrote the code wrong, or you did something else that was much more technical in nature. It is far more common that there is a human issue, whether it's human error, whether it's in terms of mistakes, or whether it's some kind of social engineering, potentially bribery, some kind of ethical issue, bad labeling, potentially either on purpose or maybe not on purpose, in your training data. Things like this are the vast majority of cases of security failures and security issues. It is not necessarily a technical issue in most cases. It's also important that we're seeing more and more dependence on human labeling as time progresses, and we see more and more complex AI systems developed as compared to maybe the more traditional statistical machine learning models from just say 10 years ago. There's been a lot of government attention here. I'm not going to go through all of these, but it's worthy to note that a large amount of government attention is being paid to making AI more trustworthy, making data privacy a bigger issue. Things like this are getting lots of attention at many different countries, from many different countries at many different levels. Again, the majority of cases where you're looking at security issues, you have this distribution where 95% of the data is benign and roughly only 5% is actually negative. And those are the small areas you're targeting, right? So your labels, your human inputs often are being used to identify this 5%. Some examples of well-known data sets in the area that follow this trend. There's a very well-known data set in the banking sector, which is a publicly available data set, has less than 1% of the data points are actually known cases of fraud or money laundering. Within the cyber, e-commerce cyber activity type cyber attack data sets, again, less than 5% is very common. And even within physical security systems, like video systems, for example, less than 5% of the data points are ever actually identified as being malicious or some kind of threat. Now, the important part of much of my work and some of the areas I want to kind of talk about today more is around this notion that AI systems are constantly getting better, particularly unsupervised systems, as architectures become more complex, that the data becomes more rich because we're collecting more data points through telemetry, things like this. And so the difference in terms of performance differences, in terms of the learning rates, in terms of how much value the human beings are actually adding to these systems, is essentially decreasing. And so yes, 30 years ago, a human may have been able to add a 20% increase in your accuracy metrics for judging things such as hate speech, fraud, whatever else you're looking at, you're removing or identifying with your AI systems. But this distance is shrinking. We are seeing that human beings are adding less and less value, and we should eventually see, as AIs get better and better and better, there's gonna be less and less need for these human inputs. Additionally, because you have all these issues surrounding the human beings themselves providing the input, again, they can make mistakes. There could be a social engineering aspect where they're bribed or they're purposely making mistakes. You could have model drift, right? You have difference in time and shift and things like that. The generally trusting of human inputs is getting less and less normalized. You should essentially trust the human inputs less and less as these systems get better and better. Other example data sets for other applications, electrical power security, trying to remove outages, things like that. Roughly, often these data sets have about 10% rate of true positives. So again, very few, 9 out of 10 points are benign. Cryptocurrency type cyber attacks, I've seen a few data sets on this as well, kind of an emerging area. Again, usually around a 5% true positive rate. And even financial documents, or often you see these things for like checks and things like this, where they're using some kind of image recognition to do fraud detection, electronic fraud detection, things like this. Roughly around 5% of data sets commonly actually have true positive rates for fraud or for threats. So I want to call your attention to the kind of emerging area of AI auditing in this particular industry, these types of products. There's a lot out right now. AI products attempt to do things like fairness and bias checking. Usually this is based on some kind of statistical analysis of what a baseline population is doing versus what other groups of populations are doing. This is one area where we're seeing a lot of companies investing in this space and things like it. There's also some cost estimation type tools coming out for performance gains of how valuable these human inputs are, either labeling, annotations, again, human in the loop, things like that. But I want to really call your attention here to the ideal gold standard. An ideal gold standard would be you have some sort of system that is privacy preserving, it is unsupervised, so you don't actually need any human inputs at any time, and it's doing something that is a task for looking at and identifying these, say, 10% of anomalous cases that are the threat, that are the problem, that are the whatever you're interested in. So some examples would be things like personal digital ID systems, with include some kind of engineering protection built into them so that your customers can use their payment systems in a way that protects their digital identity and guarantees that who they are, who they say they are, and then you receive payment in a meaningful way. Similarly, again, talking about the hate speech or hate image detection on a variety of different platforms, so it's a video game, social media, Web3, whatever it is. This is another problem that is a very hot area of active research, and many products are coming out in this space right now. And then again, the performance drift or bias prevention space, the other big one. I want to highlight here the difference between performance drift. Performance drift is where you often have new data coming in that is different than previous historical data. So your system that was trained on old data can no longer be as useful as it used to be because the data has somehow changed, whether that's due to a legal issue that changed, whether your customer population changed, whatever it is. Performance drift is often due to the fact that you have previous labels or you have some kind of previous human inputs you're basing your assessments on, your AI's assessments on, and that has somehow changed. Now your labels, your annotations are no longer as useful as they used to be. So again, this is another area where the human input factor is very important. So being able to judge the value of your human inputs prior to putting that kind of system in production becomes a highly valuable assessment to do. So I have more slides if we want to get to them, but I want to stop here. I think this is a good kind of place to stop in terms of what we're seeing coming out of the industry now, and some of the main problems that are revolving around this notion of still using human inputs in AI systems, whether or not they are actually providing as much value as perhaps the developers of the system think they are. So that I like to stop now and take any questions or comments. Brian, are we hearing me? Brian, I can't hear you. I see there's a question in the chat. How do you check to ensure if the AI systems are working correctly without human oversight? So there is a large amount of literature on optimizing unsupervised systems or systems that lack much human oversight. There are a number of statistical checks you can do depending on the domain you're in. So there's a large amount of literature on the types of distributions you should see in the data, given the particular industry you're in. So if you're in healthcare, if you're in finance, if you're in big tech, whatever it is, there are a number of empirical studies that have looked at that type of data in the past and made best estimates and done analysis to determine what types of distributions you should be seeing. And then you can build ML models that are unsupervised in nature that use this information, think like almost like a Bayesian sense, to create cutoff points, to create boundaries, to create anomaly detection systems that can recognize similar distributions to the ones you have programmed to see based on the literature. So there are a number of mathematical and computer science solutions that particularly answer this question around how do you best build a system that lacks much human oversight? And automation, of course, becomes a big part of this. How much can you actually automate? That's also an ethical line to draw, right? So at some point, you may want to have a human being take a look at things, but primarily from is the system running correctly, rather than providing inputs to yes or no, this is a threat, this is not a threat, etc. You're welcome. I've got a few more minutes. I can be here till about 11:30, most likely, and then I have to drop. Okay, if there's no more questions, I'm going to drop from the call. Thank you very much, everyone, for watching. I always appreciate people interested in my work. Thank you again.